Hello everyone, welcome back to lesson 4. Last lesson where we created the handrails at the top. This lesson we're going to create stairs. Using this cool function over here, create cylinder between points. It's very useful. So, yes. And the cylinder's gonna look like this. You see with the stairs here, there's handrails. Yeah. Okay. So go down to after it says after the create tank function, and do create a new diff function. So def create stairs. The parameters are going to be sphere radius and top platform Z. Okay, let's create the comment. Staircase with door handrails and a mid platform. The step dimensions are scaled down so that the sphere appears much larger relative to the stairs. So yeah, that's what we're doing. Alright, first let's define some important variables we're going to need to code our stairs. First is num steps, which is 20. Next is, so this is the number of steps. You can change it to how much you want, because this code is going to be smart enough to know that how to space them evenly along the thing. Okay, stair revolution is 1.75 times math.pi. Okay, this may sound confusing, but I'll explain it to you. So here you have a spiral, right? The staircase is a spiral. It's not like a circle like that. That's a bad circle, but you know what I mean. Right? Okay, let's get the middle, like over here, and take the radius. Right, and let's draw the radius of these two. Okay, and from the last lesson, you learned that 2 times math.pi in Blender, it's a full circle, right? So if this is a full circle, it would be 2 times math.pi, but it's a spiral, not a full circle. So I use 1.75 times pi instead of 2 times pi, which is smaller, like a bit smaller than a circle. Alright, so let's make this angle over here, this circle, 1.75 times pi, which is our revolution. Next is the thickness, and we're just going to base them all off the sphere radius. So sphere radius times 0.03 is our thickness. You can change this if you want. Yeah, 0.03 of the sphere radius. Step width is also like a based off the length of the sphere radius. It's going to be 0.1 of that. And then the step length is going to be 0.3 of that. And then the total stair height is top from Z minus step thickness divided by 2. Okay, so thickness, width, length, that's pretty self-explanatory, right? But total stair height, it's also explanatory. It's just the height from here to the bottom. But why do you minus half of the step thickness? No, it's not really that big of a deal, but it's kind of saying that there's like half a step difference, like either over here or over here. No, I'm not sure really, but it works. Okay, now we're going to define a little bit more, but they're like in a different section. These are like the defining the dimensions of the stairs. This one is defining other things. Yes, the radius bottom equals sphere radius times 1.5. Radius top is equal to sphere radius times 0.5. This is because if we go over here, you can see that the top stair over here, its radius to the origin is way smaller than this radius, meaning that what these defining the radiuses are just defining the length. So this one's 0.5 of the sphere radius, this one's 0.5 out of the sphere radius, like 0.5 more out of the sphere radius. Okay, next we're going to create some variables for the handrails. Handrail parameters. So first is rail v offset, which is basically the height of the handrail. No, not the handrail, like the posts over here. Actually, never mind, it's the handrail. Sphere radius times 0.25. And then rail thickness is sphere radius times 0.01. So it's pretty thin. But the post radius is even thinner. It's times 0.007. Okay, now we're going to create some lists, and they're just basically for storing important data that we're going to use later. And the variable names and what they're going to be used for is going to make sense in just a little bit. Alright, now let's make a for loop. In this for loop, we're going to have a variable called t. T is a fraction going from 0 to 1. So I divided by the number of steps. That's going to give us our fraction. The higher the t, the closer you are to the last step. And we're going to create an equation that'll get us that. Alright. Later. Okay, angle I is our next variable. And it's just stair revolution times the fraction. Basically, it makes it so that the closer are to the last step here, the bigger the angle. Because remember, the bigger the t. Like I say, I'll show you the equation first, then you'll understand. Okay. I, which is the z coordinate, because yeah, it's just the total stair height, and you divide that by t, so t gets so yeah, I'll show you. So you have the stair height, you just divide it by t, and then you get a larger chunk out every time. Like first time you get this, second time you get this, because well, t is going to get bigger as I divided by, wait, t is going to get smaller. Yeah, t is going to get smaller, and the smaller it gets, closer you are, you're going to be the higher step. So instead it's here, get a bigger chunk every time. Wait, I messed that up. The higher the t, the closer you're going to be to the top. So yeah, every time divided by a higher piece, then divide by higher, then you're going to eventually get back to the top. Okay. Linear interpretation for step center radius. So interpretation is like, this is the equation times radius bottom, and I'm going to explain it after I write it. Plus t times radius top. Alright, so 1 minus t times radius bottom plus t times radius top. When t is 0, this is 0, so times radius bottom is going to be 0. And then t times radius top. No, actually, when t is 0, then this is going to be 1. So radius bottom is when t is 0. But when t is the maximum number, which is 1, then when t is 1, then this is 0, and this is 1. So the linear interpretation will be the top. And yeah, as 0 slowly increases, then the linear interpretation will slowly get to the top. Yeah, so that's why as I gets bigger, then it's gonna get to the top. Okay, then our center, that's just gonna be our interpretation. Okay, now we need the x and y center of the center, because right now we just have the r center, which is the radius, which is the our interpretation. So I'm gonna explain it to you, and if you watch some of my last videos, then you'll probably know what's up, because I did this many times before. X coordinate, you have y coordinate, you have the point with the radius going there. The point has imaginary lines going from there. So because of this, then this length is actually never. I'm getting ahead of myself. So this is the radius, right? Radius. Oh, never mind. I didn't write the equation yet. That's the radius. Okay, our center, which is also our center. And then remember math cosine this angle, theta, which in our code is angle I. And if you remember from last time, it's radius times cosine theta. Alright, and for y, it's just radius times sine theta. Because you divide these points, so you multiply by this to get this length, which you don't know. Because cosine is dividing these two. Using this angle, which you know, because you only know this one and this, the angle of the theta, and you don't know this length, so you could use cosine to get the answer of this divided by this. Then you times it by radius to only get this, which the length of this is the x coordinate of this, and vice versa for the sine. Not vice versa, but it's like the same concept, but with these two lines instead. So x center is equal to r center times math dot cosine angle I, which is our theta. Y center is r center times math dot sine angle I. And then we're going to create okay, so since we're gonna create an object size 1.0, location is x, so basically the location is the middle of of where the step is supposed to be, and they're going to add a cube, which means that they're going to add the stair now. Okay, nice. Okay, now let's give it a name. Step object is our name. bpy.context.active object. So you take the active object, which is the step, which is what we just built, the step, and name it step object. But then we name it again stair step I. So the ith stair step. That's yes. That's what Bunder's gonna show. Step object is what we're going to use in is the name we're going to is the variable we're going to use in Python. Dimensions is step width, step length. So we're just using our defined dimensions, step length and step thickness. Alright, but now we have a problem, the rotation, because if you remember from last time I explained that it'll start upright, so I need to rotate it in. So step rotation Euler on the z-axis, so we use 2. 0 is x, 1 is y, and z is 2. And we rotate it by angle I. Alright. So why do I rotate it by angle I? Alright. Let's say we have the same radius with the axes. Alright, we have a radius like this. Alright, and on this radius we have the middle point of the step. And let's say near this radius we have this line. And this line, let's have a different color. Wait. Okay, let's make a new line. Is perfectly perpendicular to that line. Yeah, so let's make that red because it's not part of the actual line. And then we have another line which is like over here, which is a right angle towards this line. Then the angle of this will be equal to this. Not that, this. So we're gonna rotate the z, which is right now facing towards us, so that this the stair is rotating the same as this angle. No, never mind, it's not this angle, it's this angle, because over here rotate by this angle will get it this good shape, which I didn't draw it well, but if I did draw it well, then it just goes straight to the top, and then yeah, that line would go like that. So that's why angle I. And step top. So we're just getting the z-axis of the top of the stair, which isn't that hard. We get the middle z axis, which is zi, and then we add half of the step thickness. Okay, now let's start building some functions for our handrail here, and the poles that's going to support the handrail and attach it to the stairs. So outer edge. Okay, outer edge. Wait, let me first tell you. So outer edge is the outer edge, like here. And let's take, and to explain it more specifically, if you have this line going through here, it's just half of this width added on here to the length, so we get the edge that is farther away from the origin of the stair, which is going to be visible in our x and y. X, center, plus half of the step width. So step width divided by 2 times math dot cosine angle I. Because we're using the same formula basically, except we just extend this line to get the outer edge, which will get us these angles, which will get us the x and y of the outer edge of the stair. So now y center plus half of the step width times math dot sine angle I. So we just get the x and y, and the z won't really change this thing. It's just up top what we defined earlier. Okay, inner edge. It's very similar to outer edge. However, instead of adding, we subtract step width divided by 2. Why? Well, we want the inner part, which is this. So adding will get you further this way, subtracting will get you the point closer to the origin. So we want the point closer to the origin. So y center minus step width divided by 2 times math dot sine angle I. And yeah, the step top is still the z for this. And I forgot to close the bracket because the parentheses because I accidentally typed that as a zero. Okay, now we're going to use the lists we defined earlier. Outer step edges. So the outer edges of the steps. We just add these to the list. We just add the points there to the list of points. Because remember, we're still in the for loop. Okay. Now for the barreling. Outer rail is outer edge, but the the x of outer edge, the y of outer edge, so 1, and then the z is just the z of outer edge, plus rail v offset, which remember we defined earlier as basically the height or the length of the rail. Inner rail is inner edge 0, inner edge 1, inner edge 2, plus rail v offset. And then we use outer rail positions to append these two variables. Positions that append inner rail. Now we're going to create 2 for loops. Okay. And remember in the beginning of the video where I said we're going to use this function create cylinder between points again. Yeah, we're using that to create a lot of the things. And this folder, we're going to create the post. The next one, we're going to create the rails. Outer outer rail positions. I. Radius is post radius. Name is F outer rail post I. Okay, so these are our parameters for the create cylinder between points. It's the step edges, the rail position, and then the post radius, which that makes sense. Do create our posts. Now we're doing the same thing but for the inner ones, so inner step edges. Inner rail positions. Radius is post radius. Name is F inner rail post. For I in range, number of steps. Create cylinder between points. Outer rail positions. So we're creating the rails now. So we're using outer rail positions for both of them. Except over here in the brackets, it's I plus 1 because we're getting the next one. We're getting the variable of the next one because they're connecting 2 points. So those are the 2 points we need. Radius equals rail thickness. Name equals F outer rail segment I. Create cylinder between points. Inner rail positions I. And rail positions, then we get the next point I plus 1, and then radius is rail thickness. Name is inner rail segment I. Okay, close it, and we're actually done. Okay, so create stairs, radius top platform Z, So actually, our parameters are the ones you're actually going to use when we run this function. So yeah, where do we run it? Here. After it defines top platforms, you go to write create stairs sphere radius top platform z, and if I have no typos, it should work. Like this one, because it didn't add the equal sign. Okay, so oh, it's not supposed to be divided, it's supposed to be a multiplication. Yeah, run it again. Primitive cube. Oh yeah, when running this, you have to have the mesh. Inner rail positions. Oh, 3 ends. And over here it says out of range. Why? Oh wait, did I put everything in here inside this for loop? Yeah, these are supposed to be separate for loops. Okay. So that's probably the cause of a lot of the other problems. Yeah. Alright, so we have a staircase. And first of all, let's say you don't like that the stairs are like vertical like that. That's okay. Because if you go back up here, you can change just the width, like you can reverse them. And look, they're the same, they're lengthier now. But say you think they're too far apart, you just change the number of steps, and oh look, now it's perfect, right? Because there's enough, and they're the one you like them. Except it's not perfect, because if you follow my code, you can see that this part is actually stuck inside the sphere, and we don't want that to happen. So, however, we're going to do that next lesson. So this concludes this lesson. Bye.